Hello again, math people. This video I'm going to show you some different ways to find your least common multiple. This will help when doing your addition and subtraction of fractions. It's a skill you're definitely gonna need. So let's get into this. On the left I have 1/4 and 1/5, and I want to find a bottom number, a denominator, that will be the same for both of them. So there's two ways to do this. Let's do it let's see if I can get my cursor. There's two ways to do this. Okay, you can sit here and you can go, well, 4 times 4, or 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 24. Okay, so I've found the multiples of 4. I'm going to start over here with 5, 10, 15, 20. Oh look, we have a match. Bloop, bloop. Okay, so there's your least common multiple. To work this fraction, then, if you were to want to add or subtract those two fractions, you would take, we'll just do 1/4. And you have to, whatever you do to the bottom, you have to do to the top. And since the least common multiple is 20, we're going to be multiplying like so. And this is not really necessary for this lesson. I just want to show you what it's used for. So 4 times 20 is, I'm sorry, that's wrong. Basically, what does it take for the number 4 to become the number 20? Well, you multiply the number 4 by 5 to get the number 25. So I'm multiplying 4 by 5 to get this. Okay, 4 times 5 equals 20. I multiplied the bottom number. Now I have to multiply the top number just the same. So 1 times 5 is 5. So there is your least common multiple, adulterated, modified fraction that you would use for other mathematical functions later in life. I'm going to go ahead and get rid of all this because I don't like this method. It's boring. I'm a big fan of prime factorization. I think prime factorization is sexy. So we're going to do it my way. And my way is prime factorization. So I have previous videos of how to do that. We're going to start with 4. We're going to pick a prime number that goes into 4. And I'm going to branch this because I don't have room to do my little brackety thing. But we're going to do branch prime factorization. Just ignore that. Follow along. 2 is a prime number that goes into 4. And it goes in there 2 times. So 2 times 2. 2. These are both prime numbers. Equal 4. I'm going to do 5. 5 in itself is prime. So I'm just going to drop this guy down here. So the prime factored form of these two fractions, the denominators, is 2 times 2 times 5. And if you plug this into a calculator, 2 times 2 is 4, times 5 is 20. So we got that in the other method of just plus, 5 plus 5 plus 5 plus 5, and 4 plus 4 plus 4 plus 4. We found out that it was 20. It's also 20 this way. Alright, that looks great, it's neat, and there's nothing weird about this problem. This is simple. The next one, 1/6 and 1/8, I'm going to go ahead and do this. In fact, I will even do this in my little nifty upside down division bracket prime factorization technique. And what happens is you take 6 and you drop an upside down division bar and you find a prime number that goes into 6. I like 2, and 2 goes into 6 3 times. Those are both prime numbers. So now my prime factorization for the denominator 6 is 2 times 3. Okay. Now we're going to do 1/8, and I'm going to take my 8 and I'm going to do my little funky upside down bracket. 2, and 2 goes into 8 4 times. I'm going to do another bracket, and 2 goes into 4 2 times. So the prime factorization of 8 is 2 times 2 times 2. Now what happens is you've got these two. I'm moving this guy down here just so it's visually concise. You're going to find numbers that are similar in both fractions. And whichever fraction has the most of a certain number, you're going to keep. And the other fraction's going to be, that number's going to be discarded from that fraction. So 1/8 happens to have a lot of 2's, so we're going to keep these 2's. And this 2, there's not enough. He goes away. Alright? There's only 1 3, so we get to keep this number. And what happens is you take this, both of these little hunks of numbers, and you turn it into an expression, not an expression, but an equation. And when you multiply this out, you get, hold on, let me do the math real quick in my head, blah, 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 24. 2 times 2 is 4, 8, 3, 16, so you get 24. Yeah, that was easy. 24, that's a 5. They're slightly dyslexic, hold on. Alright, 24. So, you could go ahead and do the crazy, 6, 12, 18, 24 thing, and then the same thing with 8, and by the fourth 8 you would get 24. But the least common multiple for 1/6 and 1/8 is going to be 24. That I went through really quickly. You're probably confused as to this whole who gets what number and where and how you create your little equation to get your least common multiple. So let's do 1/18, excuse me. So I'm going to go ahead and put 18 here. And I'm going to put my 2 out there. 9. 3 goes into 9. These are all prime numbers on the outside. That's what I need. And 3 goes into 9 3 times. So that is a 3 from Mars. I'm learning Martian anyways. The prime factorization form of 18 is 3 times 2 times 3. That's really, you do 3 times 3 times 2. Let me do that. This is probably my most wonky video of all times. Okay, so 3 times 3 times 2 is the prime factored form of 18. So that is the same as that. There's many ways to write numbers in math. I could multiply the whole thing by 1 and put it over 1 and it'd still be the same value. Whatever. So there's your prime factored form of 18. Now we're going to do 10. 10's a smaller number. It's easy. I'm going to do my brackets because I like brackets as opposed to branching. So 2 goes into 10 5 times. And wow, there you go. There's your prime factored form of 10. So 2 times 5. Now we have a tie here. Both have only one number 2. So it's up to you which one you want to keep. I'm going to keep this one. This number 2. Because they both have 1. You can't use both. You have to pick from one side only for each number. And I'm going to get rid of this one. This side has 2 3's, this side has none, so it's automatically 18 wins for the 3 times 3, and then 10 wins for the 5. So these are the prime factors that we keep. So it's going to be 3 times 3 times 2 times 5 is 9, 18, 9, 18, 90, right? I think. Yeah, 90. So 90... I hope I did that right, is your least common multiple for the fractions 1/18 and 1/10. Again, one more, just to try to cement this into y'all's brains. God, that's awful. I hate saying that. Alright, 28. I'm going to bracket it because, yeah, 28. That's going to be 2 and 14. And 2 and 7. Look at that. Prime factored form of 28 is 2 times 2 times 7. Fabulous! And now we're going to go over to 112. Really big number, but you just take baby steps and tiny little chunks out of it, and eventually you get it. 2 times 56. 56 is such an amazing number. There's so many reasons why the number rocks. I won't go into it because I ramble, but I love the number 56. Mainly because it was the channel that my PBS was on when I was a child. Okay, so 7 times 8, 56. I like 7. 7 goes into 56 8 times. Click. 2 goes into 8 4 times. Click. 2 goes into 4 2 times. So your prime factorization of 112 is going to be 2 times 2 times 2 times 2 times 7. Alright, and then I'm going to drop this down once again so it's visually pleasing. I do my homework for math on graph paper because I have to have things lined up and, concise. If not, I go insane. But that's why I move these down onto the same line, just so it makes more sense, hopefully, for you guys. We're going to play the Who Has More game once again. Right now, 112 has the most 2s. So we're going to circle the 2s that 112 has and destroy the 2s that 28 has. Now it's a tie for 7. So since we kind of screwed the number 28 on its 2s, we're going to use its 7 just to be nice and get rid of 112's number 7 over there. So here are your prime factors that are going to give you your least common multiple. It's going to be 7 times, 2 times 2 times 2. I'm going to write it this way because it's the same thing. I just hate writing 2's out. My previous factorization videos, I've gone into why it's acceptable and sometimes preferred. All of these together equal, oddly enough, 112. So you've already got this. It's got its lowest common multiple already. All you have to do is multiply 28 by, I think, 4. God, I can't do math right now in my head. I'm terribly sorry. 28 times 4 equals 112. I was right. Awesome. So you would multiply 28 by 4 to get 112, and then whatever you do to the bottom, you have to do to the top, so 1 times 4 is 4. So at this point, right here, you could you could add or subtract these fractions and do all sorts of wonderful things, because now you have 2 common denominators. You have to have that for addition and subtraction when dealing with fractions. Fun fact, fractions are technically more precise than any decimal number. When you get into higher maths, you leave things in fractional form. Like, I know in high school they want you to convert back and forth and all this stuff and decimals and junk like that, and it's cool for some things, but fractions are in the, theoretical, sipping coffee and espresso and smoking a long church warden pipe, math world of debating. Fractions are more precise than decimals. Anyways, you didn't need to know that, but I hope you can take something away from this least common multiple video. Once again, if I spoke too quickly, or I said something, if I let, drop the F-bomb or whatever, or you want to know more, or you have a specific problem you want me to show you how to work out, please contact me. Leave me a comment in my, the comment section of YouTube, and I will attempt to help you. Have a great day. If you need anything, you know where to leave your comments. Bye.